Right, let's solve this rational equation. We have 2 over x plus 3 minus 4 over x minus 4 equals negative 3 over x squared minus x minus 12. Now when we're solving rational equations, okay, we want to get rid of the denominators. Okay, we don't like to have denominators here. Okay, remember, we're solving this. Okay, so remember, we want to solve for x. So you notice that here, all the x's are denominators, right? So what we want to do is we want to multiply each term by the LCD. Right? So if we factor the last term here, we notice we get x minus 4, x plus 3, which is good, right? What's our LCD here? Okay, our LCD is going to be the x plus 3 times x minus 4. Okay? So what we want to do then is we want to multiply each term in our original problem, okay? So each fraction here is going to be multiplied by the LCD. So if I rewrite it, I'm going to leave a little bit of space here, right? Because what I'm going to do is I'm going to multiply each term by the x plus 3, x minus 4. And this guy here will also be multiplied by x plus 3, x minus 4. And then the last term also will be multiplied by x plus 3, x minus 4. Now notice what happens in the first fraction, right? X plus 3 cancels out. What are we left with here? We're left with 2 times x minus 4. On the second term, the x minus 4 cancels out, so what are we left with here? We're left with minus, right? Don't forget about your sign. So 4 times x plus 3. And what happens on the other side here? Well, x minus 4 cancels out, and the x plus 3 also. We are left with the negative 3. So by multiplying each term by the LCD, right, we've essentially eliminated the denominators. And this is just a linear equation. We should be able to solve this guy here, right? So let's distribute through, combine like terms, and see what we get. So we get 2x minus 8 minus 4x minus 12 equals negative 3. We can combine these, right? 2x minus 4x is negative 2x. Negative 8 minus 12 is negative 20 equals negative 3. From here, I'm going to add the 20 to both sides here. Right? Remember, I want to solve for x, right? So that's going to cancel out the 20s. So we get negative 2x is equal to 17. And finally, when I divide both sides by negative 2, I'm going to get my x by itself, which is good, right? And that's going to be my answer, right? In this case, x equals negative 17 divided by 2. Okay, now we know that if you plug this guy back into the original problem, we're not going to get a zero denominator. That's good, right? So this, assuming we haven't made any mistakes, okay, which we haven't, right? And when we plug this back into the original problem, we do not get a zero in the denominator. So what does that tell us? It tells us that this is a good answer.